This is Module 17, Lesson 2. It is your last lesson of this chemistry course. We are now going to talk about half-life. So very simply, the half-life is the amount of time that it takes for some sort of sample to decrease by half. And so here you have a little visual picture just to show you, like, whatever you start with, after one half-life, you have half of it. And after two half-lives, you have half of half. So basically right here, well, let me switch colors to something that might show up on this. If we start out with a unit of 1, after a half-life, we have half a sample. Well, after two half-lives, we have a fourth, because half of a half is a fourth. Then we would have an 1/8, a 1/16, this is really hard to see, I know, a 32nd, 1/64, then what, 1/128, and as you can see, like, this is getting really small. What would this be? 1/256? Can I do math correctly? I think so. And then what would this be? 1/300, 512, I think. You have very, very little remaining. I may have messed up my math somewhere through here, but you get the gist of it, is that every time the bottom number is doubling because you're doing half of what was before it. When you get down to, like, multiple half-lives, it looks like you don't really have anything left. But in truth, I mean, you really do. Technically, you would never get down to 0. There would always be, like, some super small particle left over. So what we're going to do is we're going to look at how to do some math problems with this in order to answer questions about half-life and amounts of samples. So here's our first example problem. It says that you have 1 gram of iridium 182. It has a half-life of 15 minutes. After 45 minutes, how much would be left? Now, there's multiple ways to go about this. This is going to be my recommended method. We're going to make ourselves a chart that compares time and mass. So at a time of 0, like, that's our starting time, we have 1 gram. So I'm going to write 1 gram down here. So 0 seconds has gone by, or actually in this case it's minutes, isn't it? So we're at 0 minute. We have a 1 gram sample. Now it tells me that the half-life is 15 minutes. So I'm going to keep track of my half-life up here. In 15 minutes, 1 will have become 0.5, because half of 1 is 0.5, and you can use your calculator for both of these. Then, now you can do the top one of 2 ways. You can either keep doing another 15 minutes, or you can add them up. So another 15 minutes on top of this would be 30 minutes. We do half of the bottom. We're always doing half of the bottom, and we're always adding on the half-life up top. Half of 5 is 0.25. Then we add on another 15 minutes on the top. I'm at 45 minutes. The reason I like doing this way is because now I know to stop, because it asks me for after 45 minutes. So I still need to do half of the bottom. Well, half of that is 0.125 grams. So here's my answer. After 45 minutes, I have 0.125 grams remaining. So that's all we would have to do this problem, is keep adding the time on the top and keep taking half of the bottom. Okay, let's try another one. If you want to write the sample problems down, that's fine. I didn't give them to you in your worksheet this time. This time we have a 10 gram sample of a material with a half-life of 3 hours. It wants to know how much of the sample is left after 4 half-lives have gone by. So this one's slightly different in that it doesn't give me an amount of time, but it still tells me how many half-lives. I'm going to go back to this one really fast. If this question asked me how many half-lives it would take, then all you would do is you would do the same problem, but you would just count how many times you added time. Don't count this first one, because this is where you start. We start counting from right here. So this is 1 half-life, 2 half-lives. It took 3 half-lives to get to this, because that's another kind of problem that you could be asked. So with this one, I don't know time. I'm still going to start out with time of 0, and we're starting out with a 10 gram sample. So everything starts from this point forward. So I'm not keeping track of time this time. I'm just going to do the halves on the bottom. So the first half-life would make it 5 grams remaining. And then this would be the second half-life. We would get 2.5. And then 3 half-lives, we would have 1.25, because half of 2.5 is 1.25. And then after the fourth half-life, that would be 0.625 grams. So you don't necessarily have to keep track of the time. I can. It tells me it's 3 hours, so I can go in here and I can put 3, 6, 9, 12, but it's not asking me for how much time has gone by. It asks me how much of the sample is left. So, there's multiple ways to tweak this. Right here's my answer. So the answer to this is 0.625 grams are left. Now, an alternate question that I could have asked you would be to ask you, like how much time went by, in which case you would need to fill this in. 3 hours, 6 hours, 9 hours, 12 hours. Every time it goes by, you add another 3 hours. So if we answer that question, 12 hours. It took 12 hours to get to this. Okay, let's try another one. Now, this is another type of problem where this time I'm asking you, what is the half-life? So we're still going to have our same setup of time and mass. Our initial time is 0. Let's see what we start with. A 500-gram sample. Okay, so we have a 500-gram sample, and it wants to know the half-life. Well, the first thing I'm going to have to do is I'm going to have to figure out how many half-lives it took it to get to 62.5. So I'm just going to set out on that trail, see how long it takes me. Half of 500 is 250. Okay, I'm not filling in any kind of time up here at the top. I'm just going to leave it just like it is. Okay, so half of 250 is going to be, of course, 125. All right, so our next one, I just don't want to make any math mistakes. I could do this in my head, but I'm worried I'll screw up. I screw up a lot. Half of 125 is 62.5. Divide it by 2 again. Oh, no, I don't have to. I'm there. Hey, look at me. I'm getting ready to keep going here, and I totally don't need to. So there we go. Perfect. Look, I drew it right the first time. So here's what we have. It took me 3 half-lives. 1, 2, it took me 3 divisions to get to 62.5, which is what it asked me. And I know that I did those 3 half-lives in a span of 24.3 hours. So we're just going to divide that by the 3 half-lives that it took. So 24.3 divided by 3 is 8.1. So each of these segments was 8.1 hours. So there's our answer. The half-life of this thing is 8.1. 8.1 hours. Okay. I think this is my next to last sample problem. It says, how old is a bone if it presently contains this much carbon-14, but was estimated to have originally contained 80 grams of the carbon-14? Okay, and then it tells me that the half-life is a whopping 5,730 years. Let's start over here. My numbers are going to be big. They're just long. So at a time of, an initial time of 0, we know it had 80 grams, and I'm not going to include all of those decimal spaces because that's just a lot. Okay, so after the first 5,730 years, that would have become 40, and I'm going to use my calculator this time for the sake of our math. So after another 5,730 years, that's 11,460 years have passed, it becomes 20. I'm going to add another 5,730 years, that is 17,190. This becomes 10. Okay, add another 5,730. We're up to 22,920 years. This is now a whopping 5 grams. Okay, well, half of that I know is 2.5. Okay, so this is 28,650. So this will become 1.25. The top has become 34,380. Half of 1.25 is 0.625. So this is now 40,110. And with my next division, we will be down to our desired goal. How old is it if it has this many? So 45,840. There is my answer. 45,840 years. Now, is there a slightly easier way to have done this? Yes, there is. I won't lie. The slightly easier way would be, don't take the time to do the math up here. Just simply count half-lives. 1, 2, 3, 4, 5, 6, 7, and 8. So don't do any of this math up here. Like, just leave that blank as you go and simply, do the bottom part. Like, do 80, 40, 20, 10. Like, this is relatively simple because you just keep dividing by half in your calculator. And then at the end, go, well, it's 5,730 years times 8 times, well, you know, and I'll just double check this, make sure that works. Yes, that is the correct answer right here. So I don't care how you choose to set this little chart up. If you want to do the time at the top, go ahead. And if you would prefer to just count half-lives and multiply like I did in the red, that's fine too. You're going to get the same answer either way. Okay, I have one last problem. Because this one's a little different and you have some of these in your practice problems. This one says, by what factor would the mass of a sample of arsenic 81 decrease in 165 seconds? The half-life is 33 seconds. Now here's where this one's weird. It doesn't give me a starting mass. So you know what I'm going to do? If you have a problem like this, then just assume that it starts at 1. So at a time of 0, I have 1 unit of it. And it'll help me answer by what factor. So I am aiming for 165 seconds. So it would be easier for me up top to keep track of time with this one. So here's what I'm going to do on the bottom. I'm just going to do half of 1. Well, there's a half of it remaining. I am doing fractions this time because by what factor? I'm asking, like, is there an 1/8 of it left? Is there 1/64? And you could give me a decimal too. I mean, you could say there's 0.25 remaining, but I was kind of shooting for like a half, a fourth of it, an 1/8, a 1/16, whatever. So after 66 seconds, half of a half is a fourth, or 0.25 if you're going decimals on me. Well, 99 seconds would be up next. Half of 1/4 is 1/8, because remember when you multiply fractions, half of a fourth you multiply across the top and across the bottom. That's how I'm coming up with an 1/8. And so if you did this, obviously it would be 0.125. Well, after that, we've got 132 seconds. That would be a 1/16. And half of 0.125 is I did it that way, is what, 0.0625, I believe. And then this would lead us to 165 seconds, and half of 1/16 would be 1/32nd, or in decimal land would be 0.03125. So there is, you know, I'll take either of these as answers. There's 1/32nd remaining, or 0.03125 of the original sample remaining. So what you would do in a situation like this with no starting material is just start with 1, because that'll help us with our fractions anyway, because it's, you know, a half of whatever, a half of a whole. So just start with the number 1. So you have a practice sheet. I don't know what's happening here. That includes, there we go, that includes 16 practice problems about half-life. It will be your last practice sheet of the semester. So get to it. What are you waiting for? Go on.